Hey there and welcome. Today we are going to learn how to graph and solve inequalities with one variable. Let's go ahead and get started. All right, so the first thing we need to talk about is what is an inequality? An inequality is a statement of an ordered relationship between two numbers or algebraic expressions. That is the official definition, but what does that actually mean? It means that we are comparing two numbers or expressions together. That's really all that it means. So let's take a look at the symbols and their different meanings. All right, so we have quite a few symbols here, and this first one that we're going to look at is called less than or equal to. It means that the number is going to be smaller than something else, or it's going to be the same. The second one here is greater than or equal to. So this one, it's either going to be bigger than something else or the same. All right, this dot here, it means that something is included, and we use it when we graph. So we use this dot when we're graphing, and it just means that that number is included. The last symbol here that we have are the brackets, and those brackets also mean that the number is included, but it's mostly used for ordered pairs. All right, so that's the first set of symbols. Let's look at the second set. So this one right here means just less than. It's different than less than or equal to because it doesn't have that line underneath. It doesn't have the equality. Our next symbol is greater than, and this one just means the number is bigger. It doesn't have the equality. So that line underneath gives it equality. This one doesn't have it. All right, our open circle here means that the number is not included. And so we use the dot, the open circle, to really mean that every single number leading up to that number is going to be included, but this one's not, but it's the easiest part to graph. So an example, we'll do some examples momentarily, but an example would be like if we had that x was greater than 3. 3 is not actually part of it, but 3.0000000000000001 is part of it. But we're clearly not going to draw a graph with that many zeros because I can also add double those amount of zeros or triple. So it just allows us to have a spot to start, but saying this one's not part of it, but the very, very first one after it is. All right, and then our last one is just the regular parentheses, and this also means that the number is not included. So let's take a look at these these inequalities that we have down below here and what they actually mean, and then graph them. And I would highly suggest that we color code when we graph these, or at the very least make different graphs for each one, so when you look back later it doesn't get confusing. So this first one here says that x is less than 1. And this is one way that we can write it, but algebraically we can also say that negative infinity to 1. And we're going to use the parentheses because neither one of these points are actually included in the answer. Infinity and negative infinity are always going to have the parenthesis because it's not actually a number, it's a concept. And then whether we use a parenthesis or a bracket around the other number is going to depend on the inequality symbol that we have. But so to graph this one, if we have positive 1, this symbol here is going to tell me that it is an open circle because it is not included, and it's all of the values that you could possibly have that are smaller than 1. So I'm going to draw an arrow to represent everything smaller than 1. All right, so this next one, x is greater than negative 4. Algebraically, the way that we write it, so we say negative 4 is the small end, and it's all the numbers bigger. So we write that positive infinity, because it's everything bigger than negative 4. Again, this one is not included, so it's going to be an open circle, and we're going to represent all of the numbers bigger than negative 4. All right, for x is less than or equal to negative 3. Algebraically, we say that down here we have negative infinity with the parenthesis, and then this time because it's or equal to, we're going to say negative 3, but we're going to have a closed bracket. because -3 is actually part of the answer. So when I draw this one, instead of an open circle, it's not going to be a closed circle at -3, but it's all the values smaller than -3. All right, and then our last and final one, x is greater than or equal to 0. Again, this one has the equality, so it's going to be a bracket with 0, because that's going to be the smaller end, and then a positive infinity with the parenthesis. Infinity always has parentheses, always. Because it's or equal to, it's included, we're going to have a closed circle at 0 and represent everything bigger than 0. So that's how we graph those. So now, let's actually apply this to solving. So if I have 2x is less than 6, I'm going to solve the same way that I solve all of my problems. So I'm going to divide both sides by 2, and we have that x is less than 3. Now we need to check this before we just graph it, because we might have made a mistake somewhere. In order to check it, we're just going to pick a number that's smaller than 3, because this is saying that the answer is something smaller than 3. So let's pick 0. 0 is always my favorite number to use when possible. It just makes everything easy. So I'm going to say 2 times 0 is less than 6. Well, anything times 0 is 0. Is 0 smaller than 6? Yes, it is. So I know that my answer is actually correct. So when we draw our number line, it's a good idea to put the 0 so that we know which way you're going. And then remember that 3 was the answer that we got. Not the 6 that we checked, but 3. So I'm going to look, is it an open circle or a closed circle? And it's open because it is not included. And it's all of the numbers smaller than 3. And because I checked 0, I'm going to shade it on the side where 0 actually falls. So now I've solved it and I've graphed it. So that's that one. Let's look at our next one. So if -2x plus 7 is greater than 13. Again, we're still going to solve it the same way. So I'm going to use my inverse operations to move 7 to the other side. I'm going to divide both sides by -2. So we have that x is greater than -3. Now we need to check it. We can check any number that we want that is bigger than -3. Right, because we're saying that x is bigger than -3. 0 is still bigger than -3, so let's try 0. I'm going to say -2 times 0 plus 7 is greater than 13. Well, anything times 0 is 0, so I have 0 plus 7 is greater than 13, so 7 is greater than 13. But now here's the question. Is 7 bigger than 13? Absolutely not. It is not bigger than 13. We can't use that. It's false. So the answer that we got is not true. But why? Well, there's a really important rule when working with inequalities, and that's that when we multiply or divide a negative number across the inequality symbol, so here we chose to divide by a negative number, we have to flip our inequality symbol. Right? Remember that when we're multiplying and dividing by negatives, it means that we're actually taking the opposite. We're going the opposite way. So our sign needs to flip to the opposite direction. So instead of it being greater than, we're actually going to say less than. So let's try something where it's less than -3. Again, you can choose any number that you want. It's your choice. It just has to be smaller than -3. I'm going to try -5. So when I plug in my -5 for my x value, -2 times -5 gives me a positive 10, plus 7 is greater than 13. 10 plus 7 is 17, which is in fact greater than 13. So this is true, which means that now my answer is actually correct. Now I can go ahead and graph this. Again, it's always good to put down the 0 so that you remember which way we're going. Our next number that we need is -3, which we'll say is about right here. And it's all of the values of x that are smaller than -3. So I have an open circle because it's not included, and that is the direction that my numbers are smaller than -3. So now we have solved it and we've graphed it, and so now our problem is done. So as a recap, in this lesson we learned what the inequality symbols were, what they meant, and and how to use them and graph them. Until next time, I'll see you later. Love you, bye.